G'day everybody. This is the second part of discrete distributions. We will do a quick recap of the first part. In this lesson we're going to talk about what does it mean to measure the variability of a distribution. In particular, we'll define the variance and the standard deviation of a distribution. And finally, we'll calculate some probabilities that involve using the standard deviation. So just a quick recap of part one. We talked about what it means for a random variable to be discrete. These take on only countable values. We usually represent probabilities using a random distribution table or a probability distribution table. We always define the variable. Our table represents all of the quantities that the variable can take on and the probability associated with each one of those quantities. One of the properties of a random distribution is that the sum of all probabilities in the table is 1, and we talked about calculating an expected value, or something we can also refer to that as the mean of the distribution. And we use this formula down here to calculate that expected value or mean. So today we're going to talk about variance and standard deviation. So a distribution has an expected value. At the same time, we can also talk about how much the distribution varies or deviates from that expected value. One term that we use to talk about values like the expected value or the mean is a measure of central tendency. So the mean measures the center or what we expect from the distribution. The other side of the story is how much that distribution can vary between different values in and around that expected value. So if a distribution has a small standard deviation, that tells us that we can expect random values that are fairly close to the expected value or the mean. And the larger the variance or the larger the standard deviation, our distribution varies a lot from that expected value. It can be all over the place, not very close to the expected value. In our calculations today, we're going to use these two formulas here. So we have the formula for the variance of a distribution. You can see here it uses the expected value. It also uses something that we're going to calculate, the expected value of x squared. So it's the difference of those two quantities. We square the mean. And when we calculate the standard deviation, it's always simply the square root of the variance. You'll see different symbols used for these quantities from time to time for these measures. So I just want to be clear, when we talk about the expected value of the mean, we can use E of x, or we can use mu, the Greek letter mu. When we talk about the variance, as far as I know, the only way that we use to signify that is to use VAR for the variance. And when we talk about the standard deviation, we can use SD, or we can use the small Greek letter sigma. So we'll use those symbols today, in particular the Greek letters. So we're going to work on this example, and through this example we'll do some of these calculations. So this distribution represents the number of times that my dog barks down the driveway per hour during the day. So sometimes my dog will bark up to 3 times per hour, sometimes won't bark at all. And we've got probabilities associated with each one of those quantities. So in this example, we're going to calculate the expected value, E of x. We're also going to calculate the variance and the standard deviation. And once we've got both of those, we'll talk about calculating this particular probability. So you can see here I've started the calculations for the expected value, or the mean. So that's the sum of each of the quantities, each of the values of x, multiplied by its relevant probability. And when we sum those quantities, we get a mean of 1.3. So that's the expected number of times my dog will bark per hour during the day, or the mean or average. So let's move on to calculating the variance. You can see here I've started to calculate the expected value of x squared. So it's simply the square of each of the x values. So you can see 0 squared, 1 squared, 2 squared, 3 squared, multiplied by the respective probability for that value of x. So 0.2, 0.4, 0.3 and 1. It's a bit of number crunching for the calculator. In this particular case, we get a value of 2.5. And so we're just going to record that. So you can see here I've just made a record of our mean. That's the expected value of x squared. And so our variance is given by this formula. The expected value of x squared minus the mean squared. So in this particular case, that's 2.5 and minus the square of 1.3. That's going to give us the variance, and our variance is exactly 0.81. Our standard deviation should simply be the square root of that value. So our standard deviation is the square root of the variance. Our variance is 0.81, and the square root of 0.81 is exactly 0.9. So we've calculated our mean, our variance, which is 0.81, and our standard deviation is 0.9. Now we're going to look to the probability that's represented here. So let's pull apart this statement so we can interpret exactly what's being asked for here. We're looking for a probability that our random variable x lies in between two quantities. Those quantities involve the mean and the standard deviation. So this is the mean minus the standard deviation. That's the lower bound of our interval, and the mean plus the standard deviation will be the upper bound. And we're looking for the probability that our value of x will lie in between those two quantities. So in our particular case, the mean, which is 1.3, minus the standard deviation is 0.4, and the mean plus the standard deviation is 2.2. So another way of wording this problem is, what is the probability that the variable lies within one standard deviation of the mean, within one standard deviation below and above the mean. When you look at our distribution, remember that it's discrete, so we don't have 0.4 or 2.2 in our table, because the number of times that my dog barks, it's a discrete value. It can only take on those particular values, those particular quantities. So I'm going to simplify this statement here. So the probability that the variable lies within one standard deviation of the mean is equivalent to the probability that the variable lies somewhere from 1 inclusive up to 2. So the first discrete value that's greater than 0.4 is 1. And so that's the lowest value that this variable can take if it's going to be within one standard deviation below the mean. And if x is less than 2.2, then the greatest discrete quantity that it can be is 2. 3 is too high, that's greater than 2.2, but if x is to be less than 2.2, the largest value that it can take on is 2. And so now I can use my discrete distribution table to calculate the answer to this question. So if x is greater than or equal to 1, less than or equal to 2, it involves these two probabilities here. The sum or the combination of those two probabilities, which is 0.7. So in other words, there's a 70% chance that the number of times my dog barks is within one standard deviation of the mean of this distribution. So that completes that problem. It completes this lesson. We've talked about what it means to measure the variability of a distribution. We can use the variance or the standard deviation to measure that variability. The larger the variance or standard deviation, the more variable the random variable will be. And we've seen how in a typical exam type of question you can calculate probabilities that involve standard deviation. So that completes our lesson. If there's questions that you have from this lesson, please write them down. Complete the Google form to log your attendance and to check your understanding. Thanks very much.